In this video, I will go over the homework that follows the lecture on Introduction to Polar Coordinates. And as always, I hope that you have watched the lecture, and let's go and jump right into the homework. So the first question is asking us to draw a point in the polar plane using Desmos. However, before we use Desmos, let's figure out what's everything here means. And the first coordinate is called the radial, and the second coordinate is called the angular. And to draw the point, we're going to measure whatever the angle is in a counterclockwise direction. And once we figure out the direction, we're going to follow whatever r is, and here this will be plus direction and this will be negative direction. So if r is negative, we'll go backwards. Now, in our case, theta is 5 pi over 3, so we're going to be facing this way. And r is negative, so we'll be moving 1 unit in the negative direction, so the point will be somewhere here. Now, on this graph, it will be somewhere here. So this is 5 pi over 3, but we are moving in the negative direction 1 unit. Alright, so let's take a look at the next question. For the point plotted on the polar graph below, which of the following is the correct set of two polar coordinates for the point? So we clearly see that we are pointing in pi over 3 direction, right? But there are two ways to get here. One way is by measuring pi over 3 and then moving in a positive direction 5 units. And the other way is we can go all the way and measure 4 pi over 3, and then in that case we'll be facing this way, so we'll have to go negative 5 because in this case positive and negative will be switched. So the two answers are 5 and pi over 3, or it could be 4 pi over 3 and negative 5. Are these the only two? No, there are others. So pretty much the rule is every time you add pi, you have to change plus to minus. And if you add 2 pi, then you don't have to do anything. It's good the way it is. So choosing the right answer I guess none of them matches. So hold on, 4 pi over 3, that doesn't work. So right here, pi over 3, not this one. So alternatively, we can go negative 2 pi over 3, and then it will be we will be facing the same direction as 4 pi over 3, so the answer will be negative 5. And alternatively, we can also go like a full rotation, but none of them seem to be that large. So again, negative 5, negative 2 pi over 3, it's this one. and the other one is going this far, so it's going to be negative 5 pi over 3, and then it will be positive 5 again. So these are just some examples of polar coordinates, and it looks like this is the correct answer. Given the point in rectangular coordinates, we have to now find the polar coordinates, and let's notice that this point is in 4th quadrant. So that should help us to identify the angle correctly in the procedure that we learned. So here's the set of conversion formulas. We know that x is equal to r cosine theta and y is equal to r sine theta. So if r and theta are given, we know how to find x and y. On the other hand, we have these formulas. So when x and y are given, we can find r and theta by solving those two equations. So let's go ahead and set them up. So we have r squared is equal to square root of 3 over 2 squared plus negative 1/2 squared. That's just 1. And we have tangent theta to be equal to y over x. So it's negative 1/2 over root 3 over 2. So it's just negative 1 over root 3. And solving the first equation gives us r plus or minus 1, and solving the second equation gives us arctan of negative 1 negative 1 over root 3. And I need to make some room here. Plus pi k, and arctan of negative 1 over root 3, if you use a calculator, it will be, I can just use Desmos here. Arctan of negative 1 over square root of 3, it's that, which is 6, negative pi over 6. So we're now picking between r, for r between plus 1 or minus 1, and for theta we have negative pi over 6 and all increments of pi, so it's going to be 5 pi over 6, 11 pi over 6, 17 pi over 6, and etc. And now we just have to match it carefully. Now negative pi over 6 is pointing in the direction of the 4th quadrant, so if we choose theta to be negative pi over 6, then we can pick r to be equal to 1. Now we can make theta, here we have a condition, right? So the condition is that theta must be between 0 and 2 pi, so that means we cannot pick negative pi over 6, and we have to pick 11 pi over 6. So our answer will be 1, comma, 11 pi over 6. Now we have polar coordinates, and we have to produce the rectangular coordinates, and we're going to use this formula. So x is equal to r cosine theta, and y is equal to r sine theta. So r is equal to 8, and theta is negative 5 pi over 4. Cosine of negative 5 pi over 4 is, so we may draw a unit circle. Negative 5 pi over 4 is right here, so cosine is negative root 2 over 2. And sine is just root 2 over 2. So the final answer is negative 4 root 2 and 4 root 2. And we can always check. So for example, if you enter the point negative 4 square root of 2, comma 4 square root of 2, and then if you switch to polar grid, then you'll see that this point is exactly at 5 pi over 4, sorry, negative 5 pi over 4, which is equivalent of 3 pi over 4, and it is exactly 8 units away, right over here. So we are pretty confident that this is the correct answer. Next, we have to convert to polar coordinates, and it's very easy. We just have to measure the angle and the distance to the origin. So the angle is 0, and the distance to the origin is 4. And again, we're looking at, so here's your point, whatever that point is. We're looking at this angle and this distance. So when your point is on the x-axis, then the angle is 0 and the distance is exactly the x-coordinate. Same thing, so we can start here. So 5 pi over 6, then it is 1, 2, 3, 4. That's the most obvious answer. Now we can play with it, so we can go negative pi over 6, but then you have to go in the negative direction 4, or you can go negative 7 pi over 6. Then you again will be moving forward 4, or you can go positive 11 pi over 6 and then move 4 in the negative direction. So all these, and there are many other alternative ways, but which one matches? Let's see. So it's looks like this one is the right one. So we have rectangular coordinates. And we need to convert to polar. And here's where the point is, and we are in third quadrant. So to convert, we're going to use this conversion formulas. R squared is equal to x squared plus y squared. So in this case, it will be this. And tangent theta will be y over x, so it's -4 over -4, which is 1. Now r will be plus or minus square root of 32, which is plus or minus 4 radical 2, and theta will be arctan of 1 plus pi k. Now, the solution for the first equation is just 4 red 2 or -4 red 2, and the solution for the second equation can be expressed as arctan of 1 is just pi over 4, and we have all values which are pi or multiple of pi units away from pi over 4. So it's going to be 5 pi over 4, 9 pi over 4, also -3 pi over 4, etc. So now we have to pick such value, a pair of values for r and theta that just makes sense, that place the point in the third quadrant. And notice that if you pick pi over 4, you'll be facing this way, so you have to pick the negative value. So the only pair that makes sense, again looking at the constraints, that r must be positive and theta must be between 2 pi and 0, so that's the constraint. We have to pick the value 5 pi over 4, which facing this way, and r is equal to 4 radical 2. So the answer is 4 radical 2, 5 pi over 4. However, here we have to round answer to 2 decimal places if necessary. I'm actually not sure if we can try to enter it just like this. So 4 square root of 2, and then 5 pi over 4. Yeah, it got it. So, however, we could have also rounded to the nearest 100th. So, for example, 4 square root of 2 is that much, and 5 pi over 4 is this much. So as you can tell, this is an alternative answer. All right. We have polar coordinates. We're converting it to rectangular coordinates. So x is equal to r cosine theta, y is equal to r sine theta. R cosine theta will be, it's going to be -3 cosine -7 pi over 6, and here we'll have -3 sine of -7 pi over 6. Again, applying the formulas this way, this direction, from polar to Cartesian, is pretty straightforward. We don't expect anything to be weird. How do I get rid of this? So cosine of -7 pi over 6, we may have to use unit circle. So -7 pi over 6 will be here. Cosine is -√3 over 2. and sine will be 1/2. So the exact answer will be 3 radical 3/2 and -3/2. Again, before we enter it, we can check the work. We can enter the answer, and we can look at the Cartesian coordinates, or this is a Cartesian. We can look at the polar coordinates, so 11 pi over 6, and it looks like it's 3 units away, which is same as -7 pi over 6, 3. Right, so this is good. So 3 square root of 3 over 2 . And it seems like we finished the homework. If you have any questions, please do not hesitate to reach out.